Welcome to the REL Southeast Workshop Series on using a statewide longitudinal data system for research and evaluation. This self-paced workshop is the second of a three-part series. The first part provided basic information about statewide longitudinal data systems, commonly referred to as an SLDS, and may be accessed on the REL Southeast website at rel-se.fsu.edu/resources/SLDS. The final part of this series will explore the process of setting up an actionable research agenda for your alliance and your state. The purpose of this series is to help each state and research alliance develop a research agenda that leverages the data in your state's longitudinal data system, or SLDS. We hope to familiarize you with the nature, use, and power of an SLDS. Note that the emphasis is on using the existing data in your SLDS, and so we will not focus on research topics that would require collecting new data or using qualitative data that are not in an SLDS. By the end of the workshop series, we hope that you will have an increased understanding of why the federal government is investing significant resources on state longitudinal data systems and how they can be used to increase your ability to make data-driven decisions. Specifically, we want to help you understand the kinds of data your state collects and how research questions can be developed that take advantage of these systems. We will then work with you, your alliance, and others in your individual states to develop an actionable research agenda that encompasses research questions that are relevant to you and your colleagues and that can directly inform policy decisions. After all, ultimately, it is all about increasing your capacity to use data to inform and support policy. With that in mind, the workshop you are about to see is focused on conducting research in general and using an SLDS specifically. The workshop is designed to help you generate research questions that can take advantage of the power of your state's SLDS. We begin with a discussion of research designs, particularly the strengths and limitations of various designs and the types of questions that can be asked with each design. This is critical because there are some types of research designs that are difficult to use with an SLDS and some questions that are better suited to answer with an SLDS. So it is important to fit the design to the question and both to the available data. A disconnect at any point in the process can result in lost effort and incorrect conclusions. We will then cover the characteristics of good research questions that can be used later in creating a research agenda. To start, we will focus on research in general and research designs in some detail. Research designs may seem an esoteric topic, but the design of a research study fundamentally influences the nature of the results. It is critical to understand the strengths and limitations of different designs so you can answer your own research questions as well as interpret the findings of others. It is important to review information on the variety of research designs, as different designs enable us to answer different types of questions and with more or less confidence. There are many ways of organizing the different designs of research, from descriptive to causal. For the REL program, the Institute of Education Sciences, or IES, created a typology for different types of research and research products. This includes what's happening and what's known products for descriptive research, making connections for correlational research, and making an impact for causal research. Each of these product titles denote the type of research design, the type of question being answered, and the type of information that can be gleaned from the design used. First is descriptive research. IES calls descriptive research using baselines and trend lines, implementation or service use, and statistics and qualitative work describing the experiences of individuals, groups, and programs by the product category of what's happening. This type of research does not prove cause and effect, but it can be a useful first step in a larger research agenda or set of questions, and it can inform hypotheses that can be tested using more rigorous methods. Descriptive studies can use newly collected data or secondary data analysis from existing datasets and even document review. Administrative and longitudinal data systems are often used to conduct this kind of descriptive research. Specifically, an SLDS is well suited to descriptive research, answering questions like how many or what proportion. Moreover, the longitudinal nature of an SLDS means it is designed to answer questions about trends over time. Also, an SLDS will have data elements capturing many critical outcome measures such as test scores, graduation indicators, course enrollments and grades, and more. These kinds of measures are easy to aggregate into simple reports. Descriptive study reports often depict results on critical outcome measures that can show how frequently a behavior or outcome occurs, or the percentage of students who meet a specific criterion, such as scoring at the proficient level on a state assessment or graduating on time. Using the SLDS, a report may indicate patterns of particular groups of students graduating from a specific school or district over a number of years, and even show what percent went on to higher education institutions. These reports often highlight results of what's happening in simple and colorful graphics. In well-known research to identify indicators of student progress strongly related to high school graduation, Allensworth and Easton, working with Chicago Public Schools, used descriptive analyses to highlight very important findings. Their research questions lend themselves to answers that include counts, percentages, and trend lines. As we work through the results of the study, you will see that the findings are presented in percentages and graphically, two hallmarks of descriptive research. Allensworth and Easton defined students as on track if they earned at least 5 high school credits in their freshman year and had 1 or fewer Fs. They used the table to show the distribution of on and off track students. The percentages in the table give a good picture of whether students were on or off track and explain how students were characterized. A total of 60% of 9th graders in 2003 to 2004 were on track. The remaining 40% that were off track actually fell into 3 different categories. 23% of these students, the largest percentage, were off track because they failed 2 or more semesters and accumulated less than 5 credits. Another 14% had 2 or more Fs but had more than 5 credits, and the remainder earned less than 5 credits but had just 1 or no Fs. This analysis is considered to be descriptive because it provides simple frequency counts and percentages. Descriptive analyses also helped to begin answering the research question about the relationship between being on track and graduating. In this case, 81% of on-track students went on to graduate in 4 years, compared to 22% of the off-track students. The bar graph highlights that students who were on track in their freshman year were much more likely to graduate. While this work did not necessarily use data across sectors included in an SLDS, it is longitudinal in that it tracked students from 9th to 12th grade and looked retrospectively at each student's outcome based on their 9th grade status. This analysis of comparing rates borders on being correlational because it looks at the strength of the relationship between 2 variables. However, the way the results are presented, using percentages, remains descriptive. Note also that there are no causal statements being made. The authors do not say that being off track causes a student to drop out. Instead, they show a strong pattern and a way to identify at-risk students that is grounded in the data. The bar chart shows a trend over 10 years for students being on track their freshman year. Again, it is descriptive because it reports simple percentages, but in this case it is longitudinal. These are exactly the kinds of analyses an SLDS is designed to produce. Another type of descriptive research focuses on reviews of literature and reviews of other research. This includes meta-analyses and What Works clearinghouse reviews. IES calls this type of descriptive research by the product category of what's known. An SLDS cannot provide the kind of information needed for what's known. So when thinking about using your SLDS, you cannot ask research questions about what existing research supports or which programs or policies are evidence-based. Another type of research is correlational research. Like the product line IES uses to describe this work, correlational research is about making connections but not making assertions of causality. This type of research is very similar to descriptive research, except it includes additional variables besides the outcome measure of interest and commonly controls for other factors that might influence the outcome of interest. Typically, this research uses statistical techniques such as analysis of variance, or ANOVA, and different types of regression analysis to explore relationships among two or more variables. Commonly, a correlational analysis produces a coefficient, or R-value between -1 and 1, that indicates how closely the variables are associated and in what direction, whether positively or negatively. Coefficients can be derived from a variety of analyses using quantitative data, sometimes based on actual values or standard deviation units or ranks of the items. Correlational research can use data collected specifically for the study or existing data. In education research, we frequently see correlational analyses of school, district, or state data. An SLDS can be a very good source of data for correlational studies. The SLDS not only has the outcome of interest, such as test scores and attendance, but also the demographic information such as race, ethnicity, or gender that researchers often want to include in their analyses. Additionally, an SLDS may provide information about teachers, school administrators, and other staff that can be used in correlational analyses. The study conducted by the Regional Educational Lab in the Northeast on the connection between student and school characteristics and test results is a perfect example of correlational research. The research question focuses on a student outcome, in this case performance on the 11th grade state assessment in Maine. The interest in the study was on how different student characteristics, such as demographics, prior test scores, and school characteristics, relate to the test scores. It is not a causal study. It does not conclude that certain characteristics cause different performance on the test, but it does demonstrate if there is a relationship between them. The REL Northeast research is the kind of design and study an SLDS can support. In this case, the data for the study came from the Maine Department of Education. The study team used multiple years of prior data on each student to obtain the student's previous test scores, going back as far as middle school. Generally, results from correlational and other studies that rely on statistical results are presented in a table format. The tables typically show coefficients that measure the strength of the relationship between the variables of interest and identify which ones are statistically significant. That is, the observed relationship is not likely due to chance. Generally, statistical significance is indicated using asterisks. In the REL Northeastern Island study, discrete variables, such as gender or ELL status, are given a common numeric value, and the coefficients are the estimated standard deviation increase in assessment scores in relation to the numeric value given to the variable. For example, males were estimated to have significantly higher test scores in reading, math, and science than females, but females were estimated to have significantly higher writing scores. In the relationship between income and assessment scores, it is more likely that economically disadvantaged students will have significantly lower MHSA scores in reading, writing, and math, but not in science compared to non-economically disadvantaged students. Again, while it is easy to interpret these kinds of results as causal, the results only show that the variables are related to each other and cannot determine whether one caused the other to occur. Causal results require experiments. From the perspective of using an SLDS, you can see that data systems that capture critical demographic characteristics like economic disadvantage or special education status provide precisely the kind of data required for correlational analysis. As you consider potential research questions using your SLDS, questions that examine associations like this are ideal candidates. The fourth IES category of making an impact is reserved for the most rigorous type of research that allow researchers to explore questions of cause and effect, impact, and effectiveness. Only certain types of designs can be used to assert causal claims or claims about program impact. With experimental designs, one generally embarks on this type of rigorous research only after extensive descriptive research. Implementing these types of studies opens many opportunistic possibilities for ideas, questions, and feature studies. Many educational practices, such as the piloting of a new curriculum or program, lend themselves to this type of research if one plans for it. Impact designs require the use of random assignment to treatment and control groups. This allows one to be more confident that any differences between groups is not due to chance. Occasionally, an impact study can make use of SLDS data, especially student, school, and staff demographics. Other SLDS data that are often used are student assessment scores and course grades. More commonly, however, an impact study requires the collection of new data. A great example of a rigorous causal study was conducted by the Regional Educational Lab Southeast. REL researchers evaluated the impact on student achievement as a result of Alabama's initiative to improve K-12 mathematics and science teaching. This study demonstrates the gold standard as it uses a longitudinal cluster random controlled trial, RCT design, and asks about the effects of AMSTI on math and science achievement in grades 4 to 8. The collection of new data is sometimes called prospective data collection, and it refers to the data that must be collected from the experimental and control groups. For this REL study, they collected data from document reviews, interviews, trainer logs, and surveys, in addition to existing data from the state's education database from both the experimental and control groups. In this case, the study team randomly selected 82 schools that were then randomly assigned to the AMSTI or a control condition. This random assignment is what makes the causal inferences possible. Experimental designs begin with the hypothesis. It is a good idea to develop a logic model, or as was done in this REL study, a theory of action. It can help to graphically show what you are trying to prove. In this case, AMSTI developers believed that the most direct way to improve teacher quality was to create an in-depth, comprehensive professional development program reflective of national standards in mathematics, science, and technology, and to provide teachers with resources to support what they learned in that program. They then hypothesized that this would positively impact student achievement in math and science. Understanding the variety of designs is helpful, but the design is always based on the questions you are looking to answer. Sometimes the process of generating good research questions is rushed or overlooked, and this can result in incomplete and poorly developed questions or perhaps missing potential important questions. The following part of this workshop will focus on the characteristics of good research questions. A research question is very specific and gives us an idea about the method or approach to use and what exactly you want to study. Descriptive and correlational questions tend to be how or what is questions, whereas impact or causal questions tend to ask does, such as, does participating in this program change behavior or increase knowledge? Some guidelines about research questions include, they are reasonable, that is, it's doable to carry out the research. They are appropriate. It fits the program or alliance goals or purpose. They are answerable. Data can be gathered to actually answer the question. They are measurable, in that we know which specific indicators or measurements are used to measure the variables of interest. Research questions can be very hard to come up with, and you might not immediately know if your questions are answerable or measurable. Sometimes we need to do a little preliminary work or investigating to determine if the question is researchable. Research questions come from many places. They may be from issues or questions of stakeholders or the community. They may come from previous research or the literature. Sometimes they are from views of experts or from professional standards and guidelines. They can also be from your own experiences and views. To frame your research questions, there are some things you may want to consider. What is it you are looking to know more about? Do you have questions in mind? How do you know if they are researchable? How you frame your research question can make a difference in whether you can find answers to your question. To refine your research question, it helps to ask questions that get at more specific information you are seeking in the research or wanting to study. A good first step is to gather a list of questions like we have here. Remember the context in which the study will be conducted and interpreted. This can include political, social or interpersonal, cultural or spiritual, theoretical or epistemological, and geographic. Context can influence the data collected, the interpretation of the results, and even the composition of your research team. The information we provided in the second workshop is another step toward building your capacity to use your statewide longitudinal data system for research and evaluation. Your SLDS can be a powerful tool in helping you answer questions around topics that are important for the education of students in your state. For the next workshop in the series, REL Southeast staff will work with you and your research alliance to develop an actionable research agenda using your state's SLDS. To obtain more information about the studies described in this workshop, here are the references and web links. Thank you for participating. For more information, please contact us at the REL Southeast.